Okay, so for question number 2, it asks you describe the two main types of smooth muscle and the molecular mechanisms of muscle contraction. So first I'm going to start out with the major players of muscle contraction and smooth muscle. So we'll go ahead and start with calmodulin. I'll kind of do this little drawing here. So what happens with calmodulin is that when there is calcium, it increases intracellularly. The calcium will come and bind on to the high affinity binding sites of calmodulin, and it will undergo a conformational change, and it will look like this with 4 calcium molecules attached to it. And so what we have here is myosin light chain kinase. So this here kind of looks like a little bit of a snake that is closed off by itself. And so what happens with the MLCK is our Rho kinase, or our calmodulin, will come in with its bent conformation. It will come in here. And what will happen is our MLCK will then open up like this, because of this calmodulin with its activated calcium. And now this has become active. This is the active state of MLCK. So we will start with these starting materials and talk a little bit about the contraction of smooth muscles. So we will start here with actin and myosin, the common players of muscle contraction. And we have a phosphate here as well as ADP attached to the myosin. And so what happens in this cycle, the next step, will be this active MLCK will come in. Go ahead and highlight the same color. And it will bring in ATP. And what that will do is it will add a second phosphorus onto this myosin. We'll go ahead and draw that in red. The addition of this phosphorus here will cause this molecule of myosin to come and bind to the actin. And when that binding happens, the ADP and the first phosphorus will leave, and the myosin will go to its uncocked state, causing a contraction of muscle. So after this contraction happens, a molecule of ATP will come in and will reattach to this myosin. And it will cause this myosin to detach from the actin in a relaxation phase, because the muscle will no longer be contracted. And in order to return to this final step, to remove this new red phosphorus, we'll go ahead and introduce another player. So this here is MLCP, or myosin light chain phosphatase. And the way I like to think of it is kind of like a Pac-Man. And so what happens is this MLCP will come in here. Go ahead and label that. And it will go ahead and bite off this extra phosphorus that was added on originally by the MLCK. and that will cause us to return back to our original state here. And with the addition of hydrolysis, we can label this as the phasic category of smooth muscle contraction. So the last player of this whole system here is a protein called Rho kinase. And so Rho kinase interacts with MLCP in the sense that it will take ATP and combine with MLCP, and it will cause the MLCP to be inactive. It will add a phosphorus here that will inactivate the MLCP. So this MLCP will not be able to take off this extra hydrogen here in this step if it is inactivated. So now we will go through the process of what happens if there is an increase or there's more MLCP than MLCK, because those are the two determining factors. The MLCK is what initially will add a phosphorus that allows the myosin and actin interaction to cause muscle contraction and relaxation. And the MLCP will be the main factor in that relaxation as it takes off that extra phosphorus that was added. So when talking about this new cycle, we will go ahead and start in the same way. Here we will have the same myosin and actin that is in the cocked position. Here we will have the MLCK come in with ATP that will join a second phosphorus that will cause the myosin to bind to the actin here. And when that happens, we will go down here and we will see that the ADP and the original phosphorus are going to break their bonds, and the conformational change to the uncocked position of the myosin will cause a muscle contraction. So that is all the same as the phasic muscle contraction, but a little bit differently now. This new overflow of MLCP will be so excited that it will come in at this step and it will remove this phosphorus here before the myosin has a chance to detach from the actin. So what will happen is the myosin will be stuck. It will kind of be locked in on the actin, which is keeping a muscle contracted. And so because that phosphorus cannot be clipped off, because it has already been clipped off, this myosin and actin will stay attached and will keep the muscle contracted for a really long time. And so the time it takes for an ATP to finally come back, as well as hydrolysis to happen, is a really long time. It can take up to several hours for this to happen in order for ADP and phosphorus to bind back to the myosin to detach it from the actin. And so this is what we call tonic muscle contraction. So when talking about the two different types of smooth muscle and their contractions, phasic undergoes a contraction and relaxation that happens regularly. And so this is for things like the small intestine or digestive tract, for things like peristalsis, which is the digestion of food and the constant contraction and relaxation of the smooth muscles, where tonic is contraction for a long period of time. And this is for the smooth muscle of things like sphincters. So when comparing skeletal muscles and smooth muscles, we have a few things that make them different. So with the structure, we know that skeletal muscles are striated and contain sarcomeres, where smooth muscles are not striated and are seen as homogeneous under a microscope. And so while they both use myosin and actin, the skeletal muscle is striated with sarcomeres, and the smooth muscle is more homogeneous and all together. In terms of function of these two muscles, the skeletal muscles are to move the bones of the body, where the smooth muscles are meant to move the organs and blood vessels and heart, things like that. And they're also meant to carry out bodily functions that are involuntary. In terms of regulation, both skeletal muscles and smooth muscles are based on the levels of calcium in the cell, because they're both reliant on myosin and actin. Even though the pathways of activation are slightly different for skeletal muscle and smooth muscle, both of them are regulated based on increasing levels of calcium inside of the cell.